Today's video is about how to solve equations graphically. We're going to focus on absolute value equations. So what we want to know is 2 times the absolute value of what plus 1, then minus 3 equals 5. There's some algebraic ways to do this, but we're going to look at it graphically. We're going to call this whole thing f of x. We want to know where f of x equals 5. So what we're asking for is, what is the x-coordinate when the y-coordinate is 5? So we're going to start by finding the vertex here, which is going to be -1, -3, because this is the opposite translation of what it says and horizontally, and this is the exact translation of what this says vertically. So -1, -3, there's the vertex. The slope is going to be 2 over 1, both going to the left and to the right, up 2 over 1. And then we want to know where this function has a height of 5, or where it crosses this line here. And that's easy to see. It crosses at this point and at this point. So this side, x equals 3, and this side, x equals -5. We can easily plug these in to check to make sure that this is the case. Unfortunately, the video got cut off at the bottom, but you can see that each of these are going to turn out to be 2 times 4, which is 8, minus 3. Both of these are going to be 5. The next problem we're going to look at is where this expression equals this expression. And we're going to do a little trick here. We're going to pretend that each of these are functions. We're going to say, and we want to know where this expression equals this expression. It's the same question as asking where the height of this function equals the height of this function, because then the two y's will be equal. So again, we're going to look for the vertex, and then the slope there. Slope is over 1, down 1/2, or down 1 over 2. And this function has a y-intercept of 1 with the slope of 1 over 4, which means up 1/4 every time it goes over 1, or up 1 over 4. So we've created this system of equations, which you might be familiar with, and we want to know where this system intersects. It intersects right here at the point, and right here at the point. But since what we were asking for was the x, we only need to say 4 or -4. They do have y-coordinates here, but remember that y was an invention that we made up. There is no y in this original problem, so we're not actually asking for it. It's just a step to help us figure out what's going on. It allows us to figure out where these x's are going to give us the same height. We don't actually care that the height is 0 or +2. We just want to know where the x's show up. Now here we have a problem. We're going to do the same thing. We're going to call this one function, and this one is going to be another function. And while I know where the vertex is of this graph, and I know what direction it's going, I really don't know much about this function at all. So I'm going to turn to the computer to do all the hard work for me. Open up the Desmos calculator, or whatever your favorite graphing software is. Type in the 2 equations that we have written down, and then we're just going to look for the intersection points, which the calculator should do for you. If you're going to show this work without having someone be able to see what you can see on the computer or on your calculator, just draw a sketch of what you see. This function has a vertex somewhere around here and it's going up, something like that. This is an art class. It doesn't need to be perfect. We just need to get a general idea of what it is you're looking at and how you know what the answer is. This function and these intersect at these 3 points. And again, all we care about is the x-coordinates. So, if you're going to solve a question graphically, I want to see what you've put into the calculator. Color coding is nice. You can also write it like this. I want to see what the graph looks like. And then I want to see what points on the graph you're looking for to find your answers, and then what those answers are. And that is how to solve equations graphically. You can do this with whatever equations you want to do. You don't have to solve algebraically all the time. Some equations, like this one, cannot be solved algebraically, and you need a method like a graphical approach. Thanks for watching. I hope you enjoyed this and you learned something about solving equations.